Hello guys, my name is Diego Pacheco and this is another Rust video. Today we're gonna learn more about struct and traits. So let's get started and create a Rust project. And first of all, in my cargo.toml I don't need dependencies, so I'm ripping off clap. This is a script I have to generate the project for me. And now so let me compile and run. Let's always start with something working. Okay, it's fully working, so let's get started. So traits are a way for us to work with contracts or interfaces in Rust. So Rust is not an object-oriented language, but we have some similar capabilities called traits. And you cannot create classes in Rust, but you can create a struct like you will do in C, and then you could use that struct to represent like a Pojo or anything you would do in object-oriented programming. So let's get started then, okay? So first of all, let's define a trait, right, which is kind of an interface, and let's say it's called animal, all right? And according to animal, an animal need to be able to greet you because animals are very polite. So I'm gonna receive the self reference of the object itself, and I'm gonna return a string, right? Pretty straightforward. So this is the trait animal. Now we can create some animals, so like a cat or a dog. So let's create a struct very similar to C called cat, and we can say that cat has a name because cats, they do have names. Okay, so we have a cat. Um, right now, cat is just a struct, it's not an animal, but that's fine. And we're gonna create more structs. So I'm gonna create a struct named dog, which also I want to have a name, which is a string. Um, but this is two structs are not animals yet. They will be animals as soon as we implement the struct. So in order to, not the struct, the trait, in order to implement the trait, we need to use the impel, um, and then with impel we can implement the trait. So we just do impel and then we say for, and then we say what we're gonna impel. We're gonna impel animal, and we want to implement animal for um, a dog, for instance. Okay. Now, if dog is animal, he needs to be able to greet. So we're going to create a function called greet, and we're going to receive self reference, and then we need to return a string. So let's provide a proper implementation. So since a string, you're going to do string from, and then I'm going to say what the dog does, right? Roof, roof, roof. Okay. Now we have a dog implementation, right? Pretty good. Um, so we can use this, right, and see if it works. Okay. So first of all, let me remove this. And first thing we're gonna do is create a dog. So we're gonna do is let. I'm gonna call dog, and this is gonna do by dog. And then we need to provide a name. So I'm gonna say this is Max, right? And then there we have a dog. So now that we have a dog, oh, this is a str, so that's why it doesn't work. So I need to do a string from, and then it works. Okay, yeah, working. Okay, so let's try to print the dog. So we're gonna do a print ln, and then in order to print this, we'd say we want to print the dog. But hold on a second, it doesn't work. Why? Because dog does not implement display. So you can see it doesn't work. It also does implement debug, so we cannot do this, right? You see, it doesn't work. There's one useful macro called derive, and if you put derive on the struct, you get debug for free. So you just do derive, and then let me put this, and then you need to say what you want to derive. So want to derive for debug. In this way, now dog is debuggable. So this this still doesn't work because this relies on display. But if I do this, it works because this is the bug, right? So easily I can do cargo build and also cargo run. And you can see it works. We have here the name of the struct dog, the property name, and max, alright? So this way we make dog debuggable. We can do the same thing for cat. We just go here, put derive, and we wanna derive from debug. And then with this macro, now cats are debuggable, right? So let me just copy this to make it easier. So this is called cat, and this is gonna be a new cat. There's a name. I'm gonna put the name of my cat, Gandalf, right? And then I also gonna print the cat here. Okay. So if I compile it and run, you can see it compile. Now we don't have warnings because now everything is being used, and we have dogs and cats, right? So, but let's try the animal thing, okay? So right now, as you can see, dog is animal, but cat's not animal. So one thing we can do is like dog, we can call grit, and you can see this compile. But if we try to go on cat, you don't have grit method, alright? Because it's not an animal. So one thing we can do is implement animal for cat. So we just copy this code here. We're gonna implement them for cat. Then for cat, the grit will be different. Okay, and now we can grit. So let me print this. So we're gonna do dogs and cats greeting you, and then I'm gonna do dog dot grit and then cat dot grit. Okay, then we can compile this code and we can run it, and you can see it works. Dog roof roof, cat meow meow, and then greeting you. Okay, but there's one thing here that is a bit annoying, right? Which is you need to implement the trait for different animals, but like the code is similar, right? So what happens is, let's say you want to have the same implementation but different traits, right? Or the same trait for different structs. Because here, the implementation is really different, right? Because in the way that the dog and the cat they greet is completely different. But talking about the bug, right? We use the derive here, but could implemented debug in a different way, and even display could be implemented um, in a totally way, because right now, as you can see, I don't have display, right? I can only display it this because when I display for grid, actually I'm calling display from string, and string implements display. But if I do this, guys, you're gonna see that it will stop working, right? Because this is calling display on the struct dog and cat. But debug is available because of derive, so if we do it this way, then it's gonna work, right? Then I can call it, and you can see it works. But what happens is if I want display, but let's say the display is the same, right? Because I'm just gonna call grid, right? So I don't want to write two implementations for the same thing. Well, the solution for this is we create a macro, right? And I'm gonna create a macro for you guys here. So basically, what we have here, right? And let me just call them macro, right? And I'm gonna do for cat and for dog, all right? So this macro here is quite powerful. What we're gonna do is not care, cat. So I'm implementing. I need to import one thing. So you use std fmt. Okay, there we go. Now I'm saying that I'm gonna implement display for t, and t is something specified by parameter, all right? And then I'm gonna implement the fmt method. I'm write it, and then I'm calling grid, all right? And I know it always gonna have a grid because it's an animal, right? In this case, then I can do for implt for cat and dog, and then both have implementation of display now, and I have just one code. The syntax is a bit ugly, but it's how macros work in Rust. So if I delete it here, you're gonna see that now it compiles, and now we can have the same display for implementation for dog and cat. They just delegate to the another trait, the animal grid, right? And the code works. So that's it, guys. I hope you like it. See you next time.